start with the very first question on the screen today. We were doing simplification in last week's lesson, so we're just going to go through these answers very quickly. Remember, when we look at question number one, the excuse me, the instructions simplify is basically telling us to take the brackets away. Take away the brackets. Okay, take away the brackets. And how we take away the brackets is we multiply either each bracket with the other bracket, or we just multiply whatever's inside the bracket with what's outside the bracket. Okay, and we multiply those two in. All right. So in this first one over here, we're going to do FOIL. So I'm going to have that first, outer, inner, last. And if I write that out, my answer should give me a squared minus ab plus ab minus b squared. Now, I know that the two in the middle are actually like terms. So negative ab plus ab will give me a squared minus b squared. So this over here will be a squared minus b squared. All right. I wonder if anybody wants to venture to answer number 2 for me. I know it's quite easy. We've done these before. They aren't really that difficult. Anybody want to venture for an answer for me? I'm happy to take your answer. Okay, remember, we're just going to do the exact same thing that we did. Okay, just multiply the trinomial or the binomial by the trinomial. Okay, I'm just going to write this answer over here. Equals a squared minus b squared. All right, so I'm just going to multiply each of them with the first term and multiply the second with the each of them with the second term. All right, so we're going to start with the first one. X times x squared will give me x cubed. And then x times x will give us plus x squared. X times 1 will just give us x or 1x. It won't make a difference which is which. And then we can do the bottom. Negative 1 times x will give us negative x squared. Negative 1 times x, negative x. And then negative 1 times 1 will give us minus 1. All right. I know that positive x squared minus x squared will give us 0. X and minus x will give us 0. So what I actually have left here is x cubed minus 1. All right, and I'm going to ask in the comments quickly, when we see a question that looks like this last one over here, where we have this whole thing over here to the power of 2, what does that tell us about the bracket? What do we need to do with this bracket that we've been given down here? Anybody want to venture? You can pop your answer in the chat if you'd like. Hello, Langelihle. And our Kiwe, I hope I said your name correctly. I'm seeing it there, our Kiwe. Anybody want to venture what happens when I see a squared on the outside? Correct, Sia, that's it. Yes, Tseho, excellent. We're going to rewrite this bracket twice. So I'm going to write xy minus p squared times q. And I'm going to open another bracket and I'm going to write xy minus p squared q. All right, and then we're just going to do the same thing. We're going to do FOIL again. Right, so we're going to do first and outer and inner and last. Okay, this one is going to be a bit messy. Okay, it's not going to look as nice as we would hope. All right, so I'm going to get xy times xy. That's going to give me x squared y squared. And then I'm going to get xy times negative p squared q. And none of those are like terms. So we're just going to write negative p squared q xy. And then we'll do the inner negative p squared q times xy is going to give us the exact same thing. Negative p squared q xy. And then negative p squared q times negative p squared q is going to give us plus p to the power 4q squared. Okay, and I'm running out of space. So I need to just move a little bit. Plus, let me move over to the side, plus p to the power of 4q squared. All right. Okay, now I have to add like terms, and I know that this one over here and that one over there are exactly like terms. So this is the same as negative 1 p squared q xy minus 1 p squared q xy, and that's going to give us negative 2. So I'm going to write here x squared y squared minus 2 p squared q xy plus p to the power 4 q squared. And that's how you know you're in grade 10 now, because that's a lot. It's a lot. All right, we're going to be talking about factorization. Are we ready, peeps? Let's get into it. Oh, beautiful. Thank you, Tero. Amazing, amazing, amazing. All right, so we're on lesson 3 of 6. For those of you who are joining us for the first time, the two things that you've missed so far, which isn't so bad, we did the real number system. We've done the real number system, and we learned about set builder notation, and we learned about interval notation. We did that in last week's lessons. And we also learned about simplification of algebraic expressions. So basically what we just did now with the first 3 questions that we have. All right. And so if you want to go and have a look at those, I think they are available on the Watobi WhatsApp, not the WhatsApp, the YouTube channel. I was like, Watobi Facebook, WhatsApp, I couldn't remember which one it was, but it's the YouTube channel. So you can also follow us on YouTube. You can follow Watobi on YouTube, and you'll be able to access all the lessons that we did from last year on this very topic. But today we're going to be talking about factorization. And before I show you what I've got planned for today, I want to know from you guys. You can pop it in the chat, or you can raise your hand and unmute. Tell me what different kinds of factorization do we get? Who knows? Tell me all the different kinds. There's a lot. There's quite a few. So we're going to have to remember all of them. Yes, Murangi. What do we know?
Ma'am, I know there's a difference of 2 squares.
Beautiful. Difference of 2 squares. We call it dots, but it stands for difference of 2 squares. Anything else?
Oh, ma'am, there's also FOIL, but I forgot what that stands for.
Okay, FOIL is when we do simplification. So when we simplify, FOIL, and FOIL stands for first, outer, inner, last. And that's specifically just for simplifying. All right. But we do know, thank you, Morangi, there is dots. Anybody remember any others? Any others? Okay, I'll give you a hint. One of them has 3 things, and it's named after the word 3. Yes, ooh, thank you, Tero. Good. HCF. Highest common factor is one of them. Great. And then we have difference of 2 squares, and then one of them has 3 terms. Okay, yes, yeah, that's it. The trinomial. Beautiful. There's a trinomial. Right? Anything else, peeps? I know it's kind of hard to remember, especially when the last time you did it was in grade 9, but it's perfectly fine. We've got HCF dots, trinomials, and then we've got grouping. But I like to break up my HCF into a little bit more. Let me do this rather. I'm going to add in common bracket, Then we're going to go into grouping. And because this is grade 10 and not grade 9 anymore, we're going to add the sum and difference of cubes, the plus and minus of cube numbers. But we're going to get to that. We'll get to that in just a little bit. All right. So these are the 1, 2, 3, 4, 5, 6 things that we need to remember about factorization. Lucky for us, if we can learn how to factorize these 6 different ways, there isn't really much else that they can do in terms of factorization in maths. So we just need to master these. Now, the one thing I want to highlight the most, and I'm going to keep asking this over and over and over again, grade 10s. This HCF is our default setting. Do you guys know what a default setting is? Who knows what a default setting is? Think of a phone. Who's heard of a default setting on a phone? Anyone? Do you know what it is? Who's got an idea? Yes, Morangi, what do you think? What is it, or unless you actually know, what is a default setting?
Ma'am, I think it's like the normal thing the normal setting. Like it's not customized or anything. It comes like that.
Correct, exactly. It's like when you buy a brand new phone, the way the phone comes, like it still even has, if you buy a Vodacom phone, it still has that the Vodacom screensaver, and everything is just like nothing's been installed, like your TikTok, your Instagram, your nothing's on there, your default setting, right? Yes, correct, Sia. So what this basically means, guys, is whenever we are factorizing, the first thing we must always do is check for a highest common factor. Okay, I'm going to ask again, grade 10s, pop your answer in the chat for me. What is our default setting when we are factorizing? What is the default setting when we factorize? I'll give you a hint there. I'm drawing an arrow. Tell me in the chat. What is our default setting when factorizing? Thank you, Morangi, 100%. It is HCF. I want to hear it from everyone. Grade 10s, what is our default setting when factorizing? Beautiful, Tanduleti, that's it. We must always look for the HCF first. Okay, we have like millions of examples where kids are like, ma'am, this thing is not factorizable, only to find out that it has an HCF. So we always need to look for the HCF first. If there isn't one, then we can move on to the rest. Or sometimes there's HCF and then something else on top of that. So that's always the first thing that we need to look for. All right, let's get into it. I hope everybody's going to remember that, because I am going to try and trick you. But the thing to remember is your default setting. All right, let's start over here. Okay. Number one, our HCF is our default setting. And now I can't spell default. How, Teacher Coco? Default setting, good. Then we're going to get the difference of two squares. Now, let's talk a little bit more about dots. The difference of two squares. Now, this name just doesn't come from anywhere. It actually tells us quite a lot. Let's start with the first word. What does difference mean in math? What does difference mean? Who can tell me? Correct, Tanduleti, absolutely. The difference means minus. It means minus. Okay, that's the best part. Difference means minus. Now, this 2 here tells me the number of terms I have to have. I must always have 2 terms. And I know that both my numbers must be squares. To put it more bluntly, they must be perfect squares. I'm just going to fix my handwriting because wow, we Teacher Coco. Okay, now the squares part tells me that both of these 2 terms that I have must be perfect squares. They must be perfect squares. Let's look at an example. If I say to you guys that I have x squared minus 4, can I factorize this using the difference of 2 squares? Yes? Okay, let's see. Tero says yes, Tanduleti says no, Lutando says no. Okay, let's think about this. Do I have a difference? If we look at x squared minus 4, do I have a difference? Do I have a minus? Yes or no? Yes, I do. I have a minus in between my 2 terms. There we go. All right, check for the difference. Do I have exactly 2 terms? Yes, correct, Sia. Yes, good, Lutando. I do. I have a difference. I have 2 terms. And are both my numbers perfect squares? Are both of my terms perfect squares? Yes, they are. X squared is a dead giveaway because it's already squared. That's a perfect square. And what about 4? Why do we know that 4 is a perfect square? Because I can rewrite 4 as a perfect square as what? That's it. Correct, Seho, as 2 squared. Beautiful. So I know that I can actually factorize this. Yes, Sia, 2 squared or 2 times 2, 100%. I can factorize this. Now, I just have to remember that when I'm factorizing the dots, I just have to open two brackets, put a plus and a minus in one. And then all I'm going to do is I'm going to square root. I'm just going to take the square root of this side and the square root of that side. And each of those answers will go on either side of my bracket. So this will become x, x, and then the square root of 4 will give me 2 and 2. That's all. All right, give me a thumbs up. Are we okay with how to do the difference of two squares? Thumbs up in the chat, peeps. You can also raise it. Thank you, Tseho. I see you. Are we all good with this, guys? Excellent, Esmarie. Thank you. Okay, here's my next question. What if I have x squared plus 9? Can I factorize this? Yes or no? Yes or no? Tanalotu says no. Langelihle says no. Tseho says no. But, I mean, guys, come on now. I've got an x squared and I've got a 9. Of course I can, because I can find the square root of x squared and I can find the square root of 9. What's missing? Who says you can and who says I can't? If you say I can, okay, that means I'll be able to. If you say no, tell me why you say no. Sia, why do you say no? I mean, I've got two terms and they're both perfect squares. What's the problem?
Ma'am, I don't think there is a problem.
Really? Oh, look at what Tseho's written in the chat. What do we need?
Oh, ma'am, there is no minus.
Correct. That's it, Sia. We need a minus because the D in dot stands for difference. So do we have a minus? Do we have a
No,
minus?
we have a positive.
No, we don't. So can we factorize this? No, we can't.
No.
Factorize it. It's actually factorized as it is. We can't do anything further with it. All right. Thank you, Sia. Well done. Excellent work. All right. Are you guys understanding what I'm saying? If there is not a minus in between my two terms, I cannot factorize. Okay, I'm going to ask this question again. What if I have x cubed minus 8? Can I factorize? Yes or no? Well, yes, I can factorize, but can I factorize using dots? Can I use dots here? Lutando says yes. Okay, let's see. I have two terms. There's 1, there's 2. I've got a difference. I've got a minus. Morangi, what do we say? You can unmute, Madu. You don't have to put your hand up. I can hear you. You can just unmute yourself. Tell me.
Oh, ma'am, I don't think it's the difference of 2 squared because one of them is cubed.
Good. And what about 8? What do we think about 8? Is 8 a perfect square?
Yeah, ma'am, I
Can you think of a number
it's,
that multiplied by itself is going to give you 8? So I need the same number 2 times. That's going to give me 8. Can I find that? What do we think? Can we find such a number? No. Unfortunately, we can't. No, we're not going to find that number. So in this case, this cannot be factorized using dots. We can't do that. All right, so we need to make sure that every time we're factorizing dots, we've got exactly the right conditions. We cannot do it without the right conditions. Okay, so we must have 100% the right conditions. What if I said to you guys, I've got 9x squared minus 25. Can I factorize 9x squared minus 25 using dots? Yes or no? Hello, Bokamoso, welcome. What do we think? Tanolwetu says yes. Tseho says yes. Sia also says yes. Morangi also says yes. And I will agree with you guys, right? Because it meets all the conditions. There is a minus in between. I've got exactly 2 terms. And Each of these terms I can find are perfect squares. I know that 9 is a perfect square because the square root of 9 is 3. And I know that 25 is a perfect square because the square root of 25 is 5. So I'm just going to take the square root of that and the square root of that, and then I'm going to open two brackets. One of them will have a plus and one of them will have a minus. Now, I know that the square root of 9x squared will give me 3x and 3x. And I know that the square root of 25 will give me 5 and 5. All right, give me a thumbs up, guys. Are we okay with HCF? HCF is going to be easy. That's the one we're always going to be looking for. And the difference of two squares. I hope we're all good, guys. Remember, it must meet the conditions. Otherwise, it doesn't count as dots. All right. Excellent stuff, guys. Okay, let's move on. We now know what to do with dots. Let's talk about trinomials. And we're going to stop there today. We're only going to focus on these three. 1, 2, 3. And then when we come back in the next lesson, we will talk about. Okay, I will. Morangi, no worries. I'm going to do that in just a bit. All right. Okay, so remember what we do when we look for the answer. Okay, let's use a different example. Do you want to put your hand up and unmute for me, my dude, and we'll talk? Okay, x squared minus 16. Okay, let's think about that one. All right, unmute for me, my dude. Okay,
Yes, ma'am.
first, Morangi, I want you to tell me, does x squared minus 16 meet the conditions of dots? Does it meet the conditions of difference of two squares? Yes or no?
Yes, ma'am. Yes, ma'am.
Why? Tell me why.
Because there's two squares. 16 can also be like 4 times itself. And then
Good.
there's the minus sign.
And how many terms do I have?
We have 2 terms.
Beautiful, good. So it meets my conditions, yes?
Yes, ma'am, it does.
Good. So we're going to open two brackets. What are we going to do with the signs? What do my signs inside my brackets look like? One of them must
ma'am,
be a?
one of them have to be a positive, has to be a plus sign.
Good. And the other one must be?
Minus sign.
Excellent, good. Then we're going to take the square root of x squared and the square root of 16. What is the square root of x squared? It's just going to be x,
It's
dude.
X, it's X, ma'am. Yes, ma'am, it's X.
It's going to be x, right? So each of these x's will sit here and here. All right. And then on the other side of my brackets, I'm going to take the square root of 16. What is the square root of 16, Morani?
Ma'am, is 4.
Good. So I'm just going to put 4 and 4 over there.
Okay.
All right. Now, what I want us to note, Morangi, check what I'm going to do. I'm going to FOIL back out. Okay, I'm going to go first, outer, inner, last. Check what's going to happen. Okay. Hello, Amanda. Welcome. All right, I'm going to get x times x, and that's going to give us x squared. And then I'm going to get x times -4. That's going to give me -4x. And then at the bottom, I'm going to get 4 times x. That's going to give me 4x. And then 4 times -4 will give us -16. Look what happens now. I know that -4x plus 4x will give me 0. And what do I have left? I've got x squared minus 16 left. Do you guys see? Do you see how I've ended up at the very beginning? So when I factorize, I want to make sure that I have something so that if I do the simplify or the simplification of it, I'm going to end up with what I had at the beginning. Give me a thumbs up. Does that make sense? Are we all okay with that idea? Is everyone okay here? Excellent. Okay, so we must be able to remember, simplify is us going forward and factorization is us going backwards. All right, excellent. Okay, let's talk about trinomials. Let's talk about trinomials. All right. Okay, let's talk about trinomials in a little bit more detail. Now, I know that my trinomials Let me delete all of this stuff. Delete, right? My trinomials, right, are always going to be some number x squared plus something else x plus a number. So the word try, what do we think the root word of try is? What do we think? What word does it come from? Good. Yes, that's it. It comes from the word three. Okay. Okay, just give me 1 second, guys. Oh, sorry. All right. So the word trinomial means that we must get 3 terms. Correct. That's it. Yes, Morangi, exactly. Tricycle, like a bicycle with 3 wheels. 100%. Good. So how many terms are we going to look for in a trinomial? Always 3. But I want you guys to note something. If I did this, how many terms do I have here? How many terms do I have, guys? If we look at it, how many terms do I have? Good. I have 3. However, I can easily do this. I can do this. What is x plus 5x? What is x plus 5x? X plus 5x would give me 6x. Good, Tero. It would give me 6x plus 6. That's actually what I will get. So is this actually a trinomial? Not really. Not really. It's not a trinomial because I can still add the other 2 terms and make it a binomial. Correct, Amanda? That's it. It becomes a binomial. So in order for us to classify something as a trinomial, I have to have 3 different terms. Like when I give you x squared plus 5x plus 6. Can I add any of these together? Can I take the x squared and add it to 5x? Or can I take the 5x and add it to 6? Or the x squared and add it to 6? Can we do any of that? No, we can't. We don't have any like terms. So the only time we can classify something as a trinomial is if it has exactly 3 terms that are completely different. Give me a thumbs up. You guys are with me. All right, we need to make sure our conditions are spot on. Excellent, Seho. Thank you so much. All right, beautiful, Morangi. That's a Tandolwe too. Good stuff. Well done. All right. Okay, good. So we know that we're going to get a trinomial if we have something squared plus 5 plus a number x plus another number. Now, the way we're going to then factorize these is, again, we're going to open 2 brackets. We're going to open 2 brackets. Good, Tandolwe too. Now, here's the nice part about trinomials. We don't really know what the brackets are, what the signs inside the brackets are. So what we're going to do is we're going to take that one. That one is always going to be part of one of our brackets. Without a doubt, we can already go plus. We can already put a plus there, without a doubt. Now, the next thing I have to ask myself is, what do I have to multiply this number with to get a plus? So a plus times what will give me a plus? A plus times a what? Plus times another sign equals plus. What is that number? Or what is that sign, rather, not the number? What sign am I looking for that when I multiply it, it will give me a plus? Correct, Tandolwe too. It's a plus. That means in my other bracket, I must also have a plus. Okay, let me try another way. Okay, let's change up the signs a little bit. Okay, what if I put a minus there? Now, if I put a minus there, automatically, I already know that my first bracket will have a minus. Now we have to ask ourselves, I need a minus times something, and that must equal a plus. I must get a plus as an answer. So a minus times a what will give me a plus? A minus times a what? Ooh, be careful, Amanda, because a negative times a positive is not going to give us a positive. It's going to give us a minus. It's going to give us a negative. All right. So what do I need in this bracket in order for it to make it a positive? Correct. I need a minus, which means my second bracket will also have a minus. All right. I hope you guys are with me. Let's switch it up again. Let's switch it up again. I'm going to put a plus here, and I'm going to put a minus there. Right. Automatically, one of my brackets must have a plus. Now, what do I need to multiply a plus with to get a minus? A plus times what equals minus? That's it, Sia, correct. That's a Tandolochi, that's a Tero. So I know that I need a minus. So my second bracket must have a minus. Okay, give me your favorite emoji. Are we okay with the signs inside our trinomials? I need us to be 100% okay with this. Are we good? Beautiful, Tandolochi. Nice one, Desmarie. Ah, I love it, Sia. Beautiful. Amanda's like at peace. I love it. Excellent. Okay, now let's talk about the numbers that go inside, right? Now, first thing I'm going to do is I know that when I FOIL, when I do first outer, I know that for that first, I need to get an x squared as an answer. That means that I must have an x here and an x here, so that when I do the first in FOIL, I'm going to get x times x, and it's going to give me the x squared that I need. And that's why I put an x and an x there, right? Now, to get the last term, I now need to think of factors of 6, because remember, when we come to the end, I need to take 6, or whatever number is here, something times something, and that must give me that -6, and not just 6, actually, -6 at the end. Let's think of two numbers, right? That when minus will give us, or when multiplied will give us -6. Which two numbers? Let's think of the factors of 6. Okay, cool. Tandoloti says 2 and 3. Great, we can put that there. Let's put 2 times 3. All right, now let's FOIL. Let's FOIL and let's see what's going to happen. I'm going to get x times x, that's first and first. That's going to give me x squared. And then x times -3 will give me -3x. 2 times x will give me plus 2x. And then 2 times -3 will give me -6. Now herein lies the problem. If I add my like terms, which are -3x plus 2x, I'm going to end up with x squared minus 1x minus 6. But that doesn't look the same as what we have over here. I've got a 5 there. I've got a +5. So that's not going to work, right? It's not going to work. I need to find other factors of 6, because trust me, 2 and 3 are not the only factors of 6. What other factors of 6 do we have? I know that 2 times 3 will give me 6. What else will give me 6? Think of two numbers that will give me 6 when I multiply them. That's it, Seho, correct. 1 times 6. 1 times 6. Good, so I can use 1 times 6. Now, I want us to note here that we want +5. Now, if I had to look at 6 and 1, if I want +5, if I want the bigger number to be positive, which one of these, between -1, oh, now I'm giving away the answer. Between 1 and 6, between 1 and 6, which one of these two will be negative and which one will be positive? Between 1 and 6. One of them has to be positive and the other one has to be negative. Mind you, I need +5 as an answer. What are we thinking? Okay, Tandoloti says positive will be 1. Sia says -1. Seho also says -1, +6. Okay. I'm going to agree with those. Sorry, Thandalwetu. I'm going to agree with those who says -1 + 6, because -1 + 6 is actually going to give me +5. But if I did it the other way around, if I did +1 - 6, I'm going to end up with -5. And that's not what I want. I don't want -5. I want +5. So that tells me that in my bracket, I need to put the negative, the 1 by the negative, and I need to put the 6 by the positive. All right. Okay, and I want us to test this theory as we go along. All right, we're just going to focus on these 3, and I want you guys to identify as we are going which is which. Okay, I'm going to stop here. We're just going to stop at number 1, 2, 3, and 4, and that's fine, Thandalwetu. But the maths must make sense. The maths must maths. Okay, we can't be here where the pots are not happening. We must make sure that the pots are happening. Right, I'm going to ask again. Bonus points to the first person who can tell me, what is the first thing we always need to check for? What is our default setting? What is our default setting? Ah, yes, that's it. Always, always, always HCF. Now, if we find that HCF isn't working, what do we need to check for next? If there's no HCF, what do we need to check for next? Think about the steps we've just gone through today. That's it. Beautiful. Our default setting is HCF. The next thing we're going to search for is dots. Beautiful. And if it's not dots, if we don't have just 2 terms, but we have 3 terms, we know that we're looking at a what? That's it. Well done, Desmarie. Well done, Seho. We're looking at a trinomial. Excellent. All right, I need volunteers. Anybody, I need at least 4 people. I need someone to do numbers 1, number 2, number 3, number 4. Any brave soul out there want to try this? I'm going to remind everyone, for those of you who are joining us for the first time, I kept saying to the class last week, math, especially factorization. Factorization is about pattern recognition. And all we're going to do is try and spot which one of these 3 things what we've got here is. Okay, any volunteers to do number 1? I'll let you guys know. Number 1 is the easiest. So maybe putting up your hand now might be the nicest thing. Okay, Thandalwetu says he'll try number 4. That's perfect. Anybody want to try number 1, number 2, number 3? Anybody? Somebody? Okay, I've got someone for number 2. I've got now someone for number 3. I just need somebody to do number 1, which is the easiest, honestly. Can I pick on someone? Am I allowed to pick on someone? Okay, I think I'm going to pick on someone. Morangi, can I pick on you?
Yes, ma'am.
Can I pick on you? Okay, excellent. All right, HCF tells us that we're looking for the highest common factor. Yes, so remember we must look for the highest common factor in the numbers and in the variables. So let's start with the numbers. What is the highest common factor between 15 and 9?
Ma'am, I think it's 3. Oh.
It is 3. Good. Yes, 3
Yes,
divides both of them. Okay, so we
yes, ma'am.
can't just think about it as which is the smaller number. No, we're looking for a number that will divide both into 15 and into 9. And you're spot on. The answer is 3. Good. Then let's think about our variables. What is the highest common factor of x cubed and x to the power 5?
It's x to the power of 5.
Not particularly, because what's going to happen if I try to divide x to the power 5 over here? I'm going to get a negative answer. All right, so when it comes to the variables, Morangi, we always want the variable with the smallest exponent. Which one is that?
It's x to the power of 3, man.
Good, it's x to the power of 3. All right, so here's what we're going to do. We're going to write here 3x to the power of 3, and then we're going to open brackets. Now, what we're going to do is we're going to go to each of these terms, and we're going to divide them by our highest common factor. So I'm going to go here, 3x cubed plus 3x cubed. Now, let's do the math. What is 15 divided by 3?
Ma'am, it's 5.
Good. I know I'm going to get 5 here. And then what do we know about x cubed divided by x cubed? What's going to happen there?
Think, ma'am, isn't it gonna be x?
Not particularly, not x. Okay, let's think about it this way. Let me ask you a simple question, right? What is 2 divided by 2?
It's 1, ma'am.
1, good. What about 4 divided by 4?
It's 1 again.
Good. What about 5 divided by 5?
1.
1. Good. So do you see that if I have the same thing on top and the same thing at the bottom, the answer that I get is just 1? Yes? So what happens if I have x divided by x? What's my answer?
Ma'am, ma'am, I think you'll cancel it
Mathematics
out.
doesn't change. It doesn't change. Look, there's a number, the same number on top and the bottom, our answer is 1. Same thing at the top and at the bottom, the answer is 1. Do I have the same thing at the top and at the bottom? What's my answer?
It's 1.
It's 1, correct. It's 1. Now, I'm going to extend this, Morangi. What is x squared divided by x squared? What do you think my answer must be?
1.
1, absolutely. The maths is not going to change. The maths is exactly the same. Now, think about this concept that we've just looked at over here. Do you see over here that I've got x cubed divided by x cubed? What would I get as an answer?
Ma'am, you'll get 1 as an answer.
1, correct. We'll get 1. So that's the same as 5 times 1. What is 5 times 1?
It's 5, ma'am.
5. That's why Sia in the chat is saying they cancel out, because technically they give us 1, and anything times 1 is just going to be that thing. So we can actually go x cubed and x cubed cancel each other out because they give us 1. Do you see what we've done there?
Yes, ma'am.
Are we okay with that?
Yes, ma'am.
Excellent. All right, let's do the next part. Let's do this part. I know there's a plus there. Plus, let's do this part. 9 divided by 3 will give us what?
3.
Good, 3. Now over here, this isn't going to cancel out, right? Because that's x to the power of 5 divided by x to the power of 3. What am I going to get there?
X to the power of 2.
Beautiful, yes, absolutely. We're just going to keep the base and we're going to subtract exponents. So we're going to get x to the power of 2. Look at you, you legend. Well done. 100%. Excellent stuff. Beautiful.
Thank
Well
you,
done,
ma'am.
Morangi. Excellent. Okay, there's our first one down. Who said number 2? Let's think of number 2. Amandla, where are you? You can unmute for me, my dude, and do number 2 for me. But you need to tell me what kind of factorization are we seeing?
Hi, hello, ma'am.
Hello, my sweetie. Are you ready for number 2? What kind of factorization are we doing in number 2?
So in number 2, we're gonna break down x, and then we're gonna put 2 x's in each bracket.
Good. What kind of factorization is it before we even go there? What are we doing?
A binomial.
It is a binomial, but it has a particular name. Guys, help her out in the chat. Help her out. We're looking for a specific name.
Specific name.
Look in the chat. Look in the chat. Sia's got it. Lutando's got it. Sejo's got it.
Dots.
Dots. Absolutely. It is dots. It's the difference of 2 squares. And you're absolutely right. You can go ahead and open your 2 brackets. So you said, ma'am, I must open 2 brackets, and then what must happen? What comes next?
And then you put x on either sides.
Good. X, and then what?
And then since it's brackets of 2 differences, you're gonna put a plus on the first one and then a minus on the second one.
Beautiful. Good. And then what number goes on the end?
And then 2 numbers that you put on the inside are 3.
Good. 3 and 3. Beautiful. 3 and 3. Oh, my sweetie, just record time, less than a minute. Beautiful work. Well done. Well done. Phew. Amazing stuff. Thank you so much, my sweetie. Oh, guys, Amanda for the win. Well done. All right. Okay. Sia, are you ready? Can we do number 3 together? Let's go.
Hello, ma'am.
Hi, my boy. How are you doing?
I'm good, and you?
I'm good, thank you. Tell me, what kind of factorization are we looking at over here?
We're gonna do differences of two squares.
Beautiful. Dots. How do you know that it's dots? How did you know that?
Ma'am, because there's a binomial.
Good.
And
2
also
terms
because,
and?
also worked out the answer.
But we also know that there's a minus there, and we've got 2 perfect squares. Yes, remember, it must meet the conditions, otherwise it's not going to count. Okay.
Yeah.
All right. Work out the answer for me. What do I need to write? Tell me what to write.
So, ma'am, first we open two brackets.
Good. We open 2 brackets, and then?
Then we're gonna put in the first bracket, it's gonna be 2x plus 5.
Good. 2x plus 5, and then?
Then in the second bracket, there's gonna be 2x minus 5.
Well done. 2x minus 5. Excellent work. Well done. Square root that and square root that. Ah, beautifully done, Sia. Yo, you guys are just killing it. I feel like I didn't put enough questions because you guys are a little too fast at these now. I don't know. Okay, well done. Well done, my dude. Very, very well done. All right. Okay, we are going to keep moving because you guys are really, really fast at these. Tandolwetu, you are up. Where are you, my dude? Let's talk about number 4.
Hi, ma'am.
Hello. How are we doing?
I'm doing good, ma'am.
Excellent, excellent. All right, tell me, what kind of factorization are we going to use here?
We're going to use the trinomial.
Beautiful, trinomial. Okay, let's start with the easy stuff first, right? I know that if I'm factorizing a trinomial, how many brackets do I need to open?
You need to open 2.
Good, 2 brackets. So I'm going to open 2 brackets. Right. Luckily for us, we already know one of the signs. Yes? One of the signs is going to be a what?
Going to be a negative.
Good. This one is going to be a negative. Good. And then we need to go investigate. A negative times a what will give us a positive? A negative times?
A negative.
Good. Times a negative. So we now know what goes in the other bracket, a negative. Okay. Then what goes over here and over here, Sia? Remember, we always need that first term. We need to get back to x squared. So what's going to go in the first part of my bracket?
The first parts of the brackets are going to be x, and x.
Good, x and x. Good. Now we have to do the really boring stuff. Let's go and look for the factors of 42. Okay. I'll start with the obvious one. And the only reason I'm doing it because I know it's not the answer. 1 times 42. Okay. We know that 1 times 42 is not going to give us minus 13, right?
Yes, ma'am.
Let's think of other ways to multiply that's going to give us 42. What times what equals 42?
They can be 21 times 2.
Good, 2 times 21. But we know that there's no way for us to add them together for them to give us 13, right?
Yes, ma'am.
That's not going to work. 2 plus 21, no. 21 minus 2, no. None of that works, right? None of these work. Any other combination? What times what equals 42?
They can be 3 times 14.
3 times 14. I'm not sure if that's, I don't know if that's factors of, no, you are 100% correct. 3 times 14. Yes, correct. 3 times 14. Is that going to give us 13 in any way?
No.
It's not going to give us
No.
negative 13 in any way. No. So that one is not going to work. Anything else? There's one more. There is one more.
They can be 6 times 7.
Yes, absolutely. That's it. 6 times 7. Good. 6 times 7. If we add these two numbers together, what are they going to give us? What is 6 plus 7 going to give us?
13.
13. Excellent. And that's exactly what we need. But we need negative 13. So what does it tell me about both of these numbers?
It tells
They need
me
to be
that they need to be negative.
correct. They need to be negative. In fact, my brackets tell me that they both need to be negative because negative 6 minus 7 is going to give us negative 13. My goodness, Thandolwethu, you're a legend. Legend, legend, legend. Now tell me what numbers go here and there.
So on the first bracket, I think negative 6 is going to be there.
Negative 6. And in the second bracket?
And then negative 7.
Ah, beautiful. I'm going to tell you something, Thandolwethu. Even if you had written the negative 7 first and then the negative 6, it wouldn't have made a difference. You're just good like
Okay.
that. I mean, yeah. Well done. Well done. Beautiful work, dude. Sure.
Thank you, ma'am.
Okay, we're just killing it. We are killing it. Guys, well done. Sure. Okay. How are we feeling? Let me ask this question. On a scale of 1 to 10, 1 being hi, ma'am, no, I don't even understand, ma'am. It's not make sure. And 10 being, I got you, ma'am. I got you. I can do this with my eyes closed. Where are we feeling? How are we feeling? Tiffos at a 10. Okay. I see Thea's at a 2. See, we got to turn that 2 to an 8 at least. Langelish is at a 10. Luthando is at a 7. Ooh, guy, it's not even that difficult. We can try a couple more. It's not that difficult at all. I'm at like 10 with my eyes closed. Yes. 100%. Feel it. Well done, guys. All right. We're going to skip over this one for now. We're going to skip over the rest for now. I want us to practice a little bit more. Okay, so I'm going to give everybody 3 more trinomials because highest common factor, easy enough. Dots, easy enough. I want you guys to try these. X squared plus 5x plus 6. I want you guys to try that one. And then I want us to try x squared minus 8x plus 7. Okay, and then I want you to try x squared plus x. No, let me say minus x. Does that work? Oh yeah, plus x minus 20. Let's do that. All right. Now, we can all tell that these are trinomials. So what we're basically trying to do is break them down. And we've got exactly 2 minutes, grade 10s. So I'm going to walk through them with you as quickly as I possibly can. Okay. If you want to unmute and give me an answer, I'm happy for you to do that. You don't have to raise your hand. Otherwise, we're going to run out of time. Okay. So I know I'm going to open 2 brackets because this is a trinomial. So 2 brackets. Automatically, one of my brackets must have a plus. All right. And then I know that a plus times something will give me a plus. I know that my sign in there must be plus. Then I know because I need x squared, if I do FOIL, I must put an x here and an x here. Now, I want 2 factors of 6 that are going to give me 5, positive 5. Anybody can think of those 2 factors for me? What times what? I know that 1 times 6. 1 times 6 will give me 6. However, 1 plus 6 is going to give me 7. Remember, both of my signs are plus plus. Correct, Sia, well done. I know that that's not going to work. 1 and 6 are not going to work. So I can then use 2 times 3 because I know that 2 plus 3 is going to give me 5. And I need both of them to be positive. So I can do, let me do it Sia's way. I can do 3 and I can do 2. There we go. And now we factorized. Okay, I'm going to do the second one. Let's keep going. 2 brackets, right? Automatically, one of them is going to have a minus. Now, minus times what will give me a plus? Tell me in the chat, guys. A minus times a what gives me a plus? A minus times a? Correct, Tseho, that's it. A minus and a minus. Good. Right, a minus and a minus. And then I'm going to put x here and x there. I now need factors of 7. Factors of 7. 7 is a prime number, so this is quite easy. 1 times 7 will give me 7. And I know that I need -8. So I know that both my numbers must be negative. I must get -1 minus 7, and that will indeed give me -8. So I know that I must get -1 and -7. All right. Look at Sia, who was saying 2 out of 10, ma'am, but now he's getting all the correct answers. I see you. I see you. All right. That's where we're going to stop for today, guys.